everyone. We're Team C, and we're doing the influence of military tactics on cybersecurity attacks. That's Tony, Catherine, Scott, Tristan, and my name is Keegan. The objectives that we have for this presentation are to protect our machines against attacks from Team A, D, and B, as well as do our own attacks and find vulnerabilities against the system that's out there and back up any, recover our systems back from any attacks that we might have received ourselves.
Now, just to give a brief summary of our network right here, we have our protected network, protected by our firewalls, and then we have our intrusion detection system, which was our security onion. We have one of those machines. Additionally, we had 5 Kali Linux machines, ranging from .63 to .67 with a 192 address. And these were our offensive machines. So we used these to attack other machines that was outside of our subnet. Our main firewall was pfSense. And this pretty much just served as a bottleneck because Komodo was a standalone. Palo Alto originally was going to be a regular firewall, but due to complications, we had to move it over. So pfSense carried the threshold for all of our network. We had an Apache. We had 5 Apache machines. We had 5 Windows machines and 5 Ubuntu. And their ranges were all in the 10.30.10 network. And
can I just ask that when you present, you give us your name?
Okay, I'm Tony Cazares, and that was Kevin.
Yeah. Very good.
Okay, my name is Catherine. I'm going to start off with the distributed denial of service attack and compare it to a siege. The siege in ancient military, or the Middle Ages, the opposing force would come at the walls of a city and deny that city help from their allies and deny them from necessary supplies that they need, such as food and water. In a networking system, the distributed denial of service attack essentially does the same thing. It denies access to those systems.
For my attack, I was in charge of the eavesdropping, and pretty much what that is being able to monitor traffic that wasn't meant for you on the network. And we compared that to Benedict Arnold, which was like a spy/traitor. So he was being able to be privy to information about the US side and leak that to the British. So what I was trying to do as in the comparison was to monitor network traffic and see any kind of information that wasn't meant for me, and see what I can use to benefit my intentions.
My name is Scott Ordonez. I did Worms in the Siege of Kaffa. The reason why Worms are like the Siege of Kaffa is in the Siege of Kaffa it was the Golden Horde led by Genghis Khan sieging the city of Kaffa, which is in Ukraine right now. And what he did was he launched diseased and plague-ridden bodies over the walls to infect the city. And those bodies attracted rats, which spread the plague even more. And they infected the foodstuffs and supplies, hopped on ships that sailors were leaving the port, and that spread the Black Plague into Europe. And how it's comparable to worms is they have the initial injection phase, and then they spread uncontrollably and autonomously outside of your control, depending on the type of worm. So they just continuously spread and spread and spread. And one of the reasons why I did not do this attack on this network is because it would keep spreading, and there wasn't anything stopping it from spreading outside the network. And people tend to frown upon that sort of thing.
Hi, my name is Tristan Rogers, and my attack was based off the Enigma machine and how it was broken by Project Ultra in the World War II, 1930s and 40s. The way it was broken is through the use of socially engineered attacks. The Project Ultra itself could not crack the code as it was through brute force measures, but they realized if they could find words like weather in weather reports, or the fact that they pledged each and every document to their leader, Hail Hitler, they could break a portion of the code and from there be able to finish out the rest of the document. Same way Man in the Middle uses socially engineered such attacks. They don't break the entire code that's being sent through messages, but they break pieces of it, and from there are able to use algorithms to break down the whole message.
My name is Kevin Walden, and my attack was a Trojan horse. And the Trojan horse, if you're familiar with that, it was a wooden statue horse that was put in the middle of the city of Troy, which was actually to hide Greeks that was hiding inside of it, to take it over the city of Troy once everyone went to sleep. And just like the virus, like Trojan horse, is actually deceptive in nature to where you think it's one thing, but it comes across as being very malicious and have bad intent.
So, back to our network and securing it. First thing we wanted to do was secure our line of defense, which is our PFSense, which is our firewall. So what we did first was implement a set of rules, and this is just a list of on our online interface of PFSense, of the rules that we had. So the first thing we wanted to do was block all the network traffic from every team. So here we blocked every network from Team A, Team D, and Team B. Additionally, what we also did was block every Kali Linux. So that was their offensive machine to attack us. So we completely blocked them as well. And as you can tell here, we even blocked our own. So if for some reason they had access to our Kali machine, we blocked those too. And the only way that we let them open up was if one of our group members messaged me and they said, hey, I'm going to do some testing. And so what I would do is I'd open it up, and then as soon as they were done, I'd complete it and close it off and block it back.
So in addition to this, for increased security on the Ubuntu machines specifically, I implemented the IP tables. Now what this does is, if a packet or a file or download doesn't fit one of the listed criteria, it is automatically dropped. So what these rules do is, the very first one, if there's any invalid header, is there anything fishy about the way it is presenting itself, the packet is automatically dropped. And it is set, the other rules set the Ubuntu machines to only accept and allow output to ping requests and replies and traffic from local to local, so nothing going out. This was one of the reasons why we managed to stop part of Team D's attack by blocking FTP traffic out of the machine.
Another defense we employed is a little program called Deep Freeze. What Deep Freeze does is it takes at the time of installation, it takes like a snapshot of the hard drive, and then it turns around and locks the machine. You can still install programs. You can still change the password. But once you reboot the machine, it goes back to that snapshot from before the changes you made, unless the machine is not frozen. The reason for doing this one is because we actually had our passwords changed. Team A went in and changed our passwords. So the way we regained the control over our machines is we exploited a vulnerability within Windows 7. We did an unsafe shutdown of Windows, booted it into startup with command prompt, or safe mode with command prompt, then while it was booting again, shut it down again. And by shutting it down and bringing it back up, it launched startup repair. Whenever we were doing the startup repair, we did a system restore, which actually took us back to a point where we had the passwords under our control again. And then we put deep freeze on the machines. Next slide.
All right, now they also did a similar attack to the Ubuntu machines using this vulnerability, which all you have to do is open up a machine, start it, and while Grub is loading the BIOS and the BIOS select screen, you have to press E to go to the BIOS edit screen, and it lets you just edit this right here from read only to read write, and then init equals /bin/bash. Relax. And then this will load into root access for a user, so you can have complete total control of the system, including but not limited to changing passwords, installing files, removing accounts, opening ports, completely allowing access to anything, doing reverse SSH, so you have access to everything.
Now we're going to go ahead and give an example of one of our attacks Catherine was able to utilize, which was distributed denial of service.
What I actually did was called a SYN flood attack. This is just showing Wireshark. I cleared the screen out so we would have a fresh screen. And then I went to Kali 4 and ran back to the Wireshark and went to Cali 3, ran HPing 3 on Cali 3. So it's actually being ran toward one machine at the same time. Now we've got all these packets coming through being sensed by the Wireshark on Cali 1. This is actually the honeypot logs from Team A's Win 4 machine. Their honeypot did not stop my attack. The reason why is because I randomized the IP address. So even though it was registering all the SIM scans, it was coming from different addresses, so it didn't recognize it as an attack.
The next attack that we were going to do was the eavesdropping, which was under my control, but for the network purposes, there wasn't a sufficient amount of network traffic to really utilize the eavesdropping. So what I had to do was alter my attack. So the first thing I tried to do was research a way to change the default passwords. And on the pfSense, which is the firewalls forums, there was these instructions that allowed you to reset to the default passwords through physical access. So I completed these steps, and as you can see, there's a script in there that runs rsc initial.password. I did all these steps, and I was unsuccessful though. But what I was able to do was get into Team B's pfSense, so their firewall, and boot into single user mode. Once you do that, it boots you right into a bin.sh file, which you can go ahead and look around. And what I tried to do was scour through each directory. So I'm opening up files, trying to see what I can do. Can I read anything? Can I alter anything? And what I noticed in this etc directory was that rw.initial file, which was in the instructions. So I said, hey, why don't we just run that and see what happens? And what it did was, if you can see on the next slide, is it completely runs a default script. So it tries to ask for the password and username, which it doesn't have by default. So it temporarily shuts the system down. So I was able to successfully shut down Team B's pfSense for a short period of time. As these are perfect examples. So at 12, as you can see the time, it's 12:25. This is pfSense B's IP address that was functioned and able to use. And then at 12:28, it was down. So for as long as I was using that RW initial password file, there was no longer up. And then for the next two slides, you can see I successfully pinged it at 12:41, and then at 12:44, it was no longer available. So I was successfully able to bring it down.
For a man-in-the-middle attack, what normally happens is a computer will have its traffic redirected to the attacker and traffic redirected from the server so that you can encrypt or decrypt both pieces of code, much the way an Enigma machine, instead of breaking the traffic, the attacker would instead bring it down, grab the encrypted message, decode it, and then send it back to the other Enigma machine before it was even noticed. Next slide. For all intents and purposes, we couldn't perform a successful man-in-the-middle attack because our network was not a true network. It was very isolated, very small. People could read the IP addresses coming off and be, this is some very suspicious activity. Whereas a man-in-the-middle attack that's successful normally uses the vastness of the networks that it's pulling from to hide. Still, nevertheless, we were able to use KF sensor to grab traffic, and from there we were able to see their IP address, and if we wanted to, we could go ahead and pull data from it and send it to other people.
And for the attack for the Trojan horse, we have a demo to show you in just a second, but to start your Trojan horse, you actually have to create one using Metasploit, which is actually an application that comes installed on Kali Linux. And the command that I used to create my Trojan horse was the one that's at the very top, the MSF Venom -P Windows Interpreter reverse _ TCP and the L host. The host name, the host IP address is actually the Kali machine that I was using to actually make the exploit happen. And the L port, which is the port that I wanted the actual traffic to go through, which is 4444. And I named my Trojan payload calculator.exe because all machines have calculators, so it'd be easy for someone to click on that. So once I did that, I copied the calculator.exe to a my shares folder under the var www.html file, which is actually on the Kali machine. And using social engineering, I actually uploaded that to the target machine through the web browser, which you will see right here is going through that. It actually has the calculator down here already downloaded, and I'm starting the exploit right here to where it's going through. This is actually starting, it's initializing it, setting the payload right there to go through, and it's going to enter the host IP address, which is going to be the calendar machine that I was using. Then the next one will be the port, which is 4444, just like the payload that was created. And then I will go ahead and run it. But I was going to use this, the exploit -J-Z, and what that does is it runs in the background, so it actually starts going through. And over here you'll see, once this is initialized over here, and then you go to run it, it's going to actually start up, and you'll see a session comes up right at the bottom, to where it tells you that a session has been opened, which is session number 1. And with session 1, I'm able to actually connect to it using the command where I type sessions -I and number 1. And once it's actually loading, I'm able to see anything that's going on in the computer. I can see the file system that they have, any program that they have running. If they have a webcam, I can do that. But I decided to actually capture some text. And since Dr. Ho said that we would actually have guests that was coming in today, Team C typed out, "Welcome guests." And down here you'll see once everything is finished, I will be able to run a command called keyscan_dump, and that will actually put down right here the actual text that is actually written up at the top. And once it's finished, it will capture every single thing. So you see it type "welcome guests," I hit the enter key, and at the bottom it'll show "welcome guests," and I hit the return key. So it captures everything that the previous machine would actually be doing. So it doesn't matter what they do. If they had cap lock, it capture that as well.
So just to give a brief summary, we were attacked by other teams. Team D attacked our PF Sense, which was compromised, which we were able to reconfigure and gain under our control. And Team A successfully attacked all of our Windows, our Ubuntu, and our Apache machine by changing our usernames and our passwords. And so that was what was affected by our network, which we were able to secure through our deep freeze and our IP rules and our IP table rules. So just to sum up, some future possible exploits is social engineering. Because the network wasn't really used as like a real network with people actually using it, we just attacked and then got off. You can really socially engineer people, have people click on emails, links, all different kinds of stuff, which we could do. And to prevent that is pretty much just training, educating the user about computers, what malicious stuff is out there for people to be attacked by, and pretty much just educate the user. As far as the U.S. infrastructure and vulnerabilities, everything is reliable on the internet, whether it be power grid, whether it be the internet itself or banking system. So the U.S. is very vulnerable to all this infrastructure, and it's important for us to get an education in this system and to really go out there and try to be proactive as much as we can. And I think the best way to prepare for our country's infrastructure is to create some kind of programs, and really benefit from the STEM program. Do you guys have any questions for us?
Catherine, a system restore brings back your passwords?
Yes, it does.
I didn't realize that.
What the system restore does is periodically your machine will automatically set a store point. So it's usually when an account is updated, when a program is installed, or when a store point is manually created. So by restoring to an earlier point, restore it before the password was changed so we can get back in.
Okay, very good.
Jerry?
I'm Jeremiah from Team A. So at previous firewall rules, you blocked everything, and even went so far as to explicitly block all RFPs. But do you think for normal business operations, that's an acceptable way to run your firewall?
It is not, simply because for a normal business, you would not know every IP. And especially with 10 dot IPs, there are a multitude of legitimate organizations that have 10 dot IPs. So this would only work since we explicitly knew the IP addresses of the entire class.
I was interested in the randomization. How was that performed? What tool or software?
That was actually part of the HPing3 tool that I used in Cal. Part of the command is --rand-source, and that actually randomizes the source IP address.
Good.
Any other
I have
questions?
one question regarding your attempt to take down the PF Sense. Was it C or B PF Sense you took down?
We took down Team B's.
Okay, yeah, the next slides.
We were testing from a Team C. So we went to their GUI, that's their IP address. And that's why you could see the top. What she's asking is this border right here symbolizes what team we're using. So you can see 477C says that I'm on my team's Kali Linux. If you go back to the previous slide, you can see on this is the PF Sense of Team B's. So that's what we were attacking.
Okay, very good. The reason I'm asking this is that we have a way from top of the left-hand corner, you are able to see 4777 Team B's machine. Team C actually attacking Team B's PF Sense from their Kali. Great job.
All right, any other questions? All right, thanks for your time.